Hello and welcome to the On-Premise IT Podcast, the only podcast that dares to be both on topic and on location. My name is Tom Hollingsworth and I am a part of Gestalt IT, and each episode we bring you the perspectives and opinions of a group of IT luminaries, experts in their field, and we debate a subject, or a premise, if you will. I'd like to take a moment for our guests to introduce themselves today before we jump into the premise for this episode, starting with Kerry.
Hi, I'm Kerry Kulp, founding partner of Velispan.
Hi there, I'm Peter Mackenzie. I'm a Wi-Fi consultant and trainer based in the UK.
Hi, I'm Mohammad Ali. I work as a solutions architect for Imperium Data.
All right, thank you very much for joining us. Let's jump into the premise for this episode. As you guessed by the fact that we have three wireless experts in the room, we're going to be talking about some of the technology that is involved with wireless. Specifically, how do you figure out where all of those access points go? Do you just guess? Do you throw darts at the ceiling until one of them sticks? Or do you use a little bit more, help? There's a lot of ways you can do that. There are old school ways of doing it with painter's poles and walking around with carts or segways. But the hot new thing to do is to use software. And thanks to the help of magical AI, I can do all that I need to do just based on a fire escape map of your building, and it'll work just fine. That's called a predictive site survey. And many of wireless experts the world over who are watching this podcast right now are currently gnashing their teeth at the thought of never stepping foot onto a location. Because the premise for this episode is that predictive site surveys don't work. Now, this topic is engendering a little bit of discussion and a little bit of head nodding and things like that. So I think these three might have an opinion on it. So let's just open this up. Maybe I guess the best place to start would, because I'm not a wireless person, what is a predictive site survey? How does a predictive site survey change the game?
So it is just a predictive, just like the word, it's predictive. And whenever somebody asks me for it, I tell them, listen, this is exactly predictive, which means we're just predicting it. I haven't been on site, which means I don't know. It might be 100% wrong. It might be 50% wrong. So it's just a very high level, approximate, maybe for budgeting reasons that you might need to get. Hey, how many approximate APs I will need? It's just that. That's it. There's nothing more to it.
And when we say predictive, what we mean is we're taking into account the model of access point based on the maximum power that we know that it's allowed to transmit at, based on the antennas that could be installed on it, and we're using that RF map to basically plot and say, this is where we think the RF is going to go in this building, and this is how many access points you would need to cover it. If you want to adjust certain variables, it can tell you, what a different radio pattern looks like or what different power levels look like. It seems pretty easy. Like, I can remember years ago doing this. I'd get a fire escape map from a school, and I'd plug in everything, and I'd drop an AP down, and in a lot of cases, it'd be like, no, you need like 10 to cover this whole area, and everything will work. So what's the challenge? Because you said, you have to warn your customers. It's like, this is just kind of a best guess.
Yeah. So the keyword, like you said, it's I think. I'm not certain. I mean, that's the keyword right there, right?
You're 100% right. There's no certainty in it, right? It's the epitome of garbage in, garbage out. If I input garbage, I get garbage out. However, if I input good data, I can get good data out. And I think it's a little bit unfair to say that it's calling it just predictive and saying it's just predictive and not actually telling what really happens. There are complex mathematical models that go into it, right? So the software that we use, whether it's Ekahau or it's IB Wave or whatever it might be, I would make an argument that some of them do it better. Some environments are better suited for it. But those mathematical models output a predictive model of what RF coverage will look like in that environment based on wall loss values, free space path loss, a number of different things, reflection and refraction. There's so much that goes into it. Just calling it simply a predictive model, I think doesn't do it the service that it is warranted. Now that said, I'll let you go in a second. I'm not fully on board saying that a purely predictive model on its own is the right way to go.
Okay. I don't like the term predictive site survey.
Why?
And I don't think it should. And I think if we're going to talk about whether it works or not, we've got to define what it is, first of all. Well, first of all, it's not a site survey if you're not on site. And and different people use that term to mean lots of different things. So if you're using the term predictive site survey to mean I don't go on site, I take no measurements at all, I just allow the software model to work, and I use gets values for the attenuation values of the walls, then I would probably agree it doesn't work very well. But I also might use the term predictive site survey to mean I've been on site, I've measured the walls, I've taken some measurements, I've put all that measurement data into the software, created an RF model which allows me to accurately model the building. In that case, I would say it does work. So it's not a term I would ever use at all. I would say that the activity I do is Wi-Fi design. And in Wi-Fi design, I have lots of tools available to me. RF modeling, which encompasses what you might call predictive design, is a tool. AP on a stick measurements is a tool. Wall attenuation measurements is a tool. And there's all these different tools I can use in creating an RF design. But I would never personally say I do a predictive site survey.
I just want to say we internally inside my company had a back and forth set of discussion about exactly what we should be calling it, and I couldn't possibly agree with you more. It is not a predictive site survey. We call it either WLAN design, RF design. That's what we call it because it isn't a site survey. Now there might be a site survey component to it if we're doing a validation of our model. We might do some predictive modeling, go on site and validate, or maybe we flip that and we go on site and gather some wall loss values and then do a predictive model and then validate. But yeah, it's not a site survey.
And if you do design without any, you can do design badly and you can do it well, can you? Yep. And if you do design without any sort of on-site measurement or any sort of on-site data, there's sometimes when that's all you've got, and you've got to do that. The building's not built, you don't have any idea. And that's why I say it's a tool that we can use. But that tool of RF modeling, we can, if that's all we've got no access to the building, it doesn't exist yet, that's all we've got. If we can supplement that with real measurement data, then we can make that model more and more accurate. So it's more about creating an RF model and then using the tools we've got to make it as accurate as possible.
Educate that model along the way.
And if we don't have that data, the model will be less accurate. And we just have to let our customers know that. But I would call it more RF modeling, I think.
So predictive. So I guess if you really have to call predictive for reasons, because that's a very general term that's just in the wireless industry gets used. I would say RF modeling. If I'm strictly doing RF software modeling, that would be more like predictive survey. If I do go on site, only then I can call it predictive site survey. Kind of like. I probably would use that approach. So I mean, I would never say that, hey, I'm doing a predicted site survey, because I'm not. I've never been on site, just like you said, right? So, but if I'm just doing RF modeling using some kind of software tool, that would be just predictive survey.
But you take your on-site measurements and put them into that same RF model.
But sometimes
that same software.
Right, but I might not have those measurements, right?
No, so
I
you
might
might
not even
not
have them. Like if the building is never
But both cases, you still do RF modeling.
Yeah,
you're just doing it. You're just not adding extra measured data into it.
Correct. Yeah, correct.
So let me ask this question, because it sounds like the evolution of what we're actually doing, there's a lot more nuance to it than simply just calling it a thing that we've used in the past. On the flip side, having worked for a reseller in the past, customers don't always ask for the right thing. And so they see a term, they plug the term into their RFP, and they want that thing. And to quibble on your language, Peter, because I absolutely agree with you, but to me as a customer, a wireless site survey, a predictive site survey, is a project with a beginning, a middle, and an end, and a cost and a result. RF design feels nebulous, like it might never end, that you could bill me forever for that. And I don't want that, Peter, because...
No, but I want that.
Look, I've seen what you charge. And while it's great that you deliver the value, I want to be able to say to my executives, Peter said this works. Yeah. So how do we convince people that it's important to understand that? Because, as one of the other delegates, John Kilpatrick, brought up, a lot of times, especially in new construction, these things are done before the building is finalized. So maybe they decided to put a different kind of sheetrock in, or they actually said, instead of using sheetrock, we're going to use some of their new building material, and that can change what was actually originally determined, whether it's predictive or not.
Yeah.
So how can we help people understand that there's more nuance to it than that, other than writing a bigger number at the bottom of the proposal?
So I think the simple fact of it is that it's not always practical to do a full AP on a stick site survey, whether it's because the building doesn't exist or it's because it's just cost ineffective, right? I mean, sometimes the customer will just come back and say, I can't pay you to walk around 10 million square feet. So they just won't do it. Now, we've been fortunate. We've been able to get most of our customers to agree to it. We've been around for almost 20 years at this point, and that was the bulk of what we did for most of those years. But I think the challenge is, first of all, educating them. It is still predictive, right? No matter what, even if we do validate, we go on site, we do take those measurements, we might grab data from, let's say it's 10% or 20% of the AP locations that we think we're going to use. We could still miss the fact that they moved the CIO of a hospital, they moved her office into what used to be a radiology lab. Lead-lined walls that we would never have known unless we did the walkthrough there, right? There's always a risk.
I think that's it. It's balancing risk. It's putting a project plan together. So we do that. It always starts off with, I call it a design workshop, but it's gathering the requirements. And then if that's on the customer side, then I might do my initial measurements, take some wall attenuation measurements after that meeting. But there's a process, and you measure risk. If the building doesn't exist, then there's more risk in the design, and we tell our customers that. AP on a stick, you don't need to do every location. Again, it's a tool. So I often use it to, ultimately what I'm doing is trying to validate my RF model, my predictive. I'm saying, okay, it's predicted this. If I put an AP here, do I get it? If I do that in 2 or 3 spots, and it's close enough, then I can start to trust my design.
More of a hybrid.
No, very often. Sometimes, and when do you do it? You can do it before you do your modelling, you can do it afterwards. So long as I've got that measurement, then I do my modelling. I can go back and go, well, I had an AP here. Does it match? Yes, it does. I might not want the AP there, but creating an RF model now allows me to move my APs around and choose the best positions, not just where I happened to finger in an air when I was put my AP up on a stick.
Correct, yeah, so more of a hybrid approach.
So
like
it's much more hybrid.
Yeah, if you have like a million square feet of like area that you need to cover, and obviously if you throw that big number at a customer, they might just say no because they just don't have the budget.
Absolutely.
So you either lose that business or you offer them more of a hybrid approach. We'll do the areas because if it's a big, large office environment, it might be just drywall. But I still like the idea of at least walking around different areas to validate that those walls are at some kind of validation that those walls are what they're saying that they are.
I used to argue that years ago that predictive design was more accurate than AP on a stick design, right? To be controversial here. But what I meant by predictive was how I did predictive, which was I go on site, measure the attenuation of walls. So I've got a real live measurement, I'm putting it into a RF model, and I'm validating that model. If you do AP on a stick, first of all, you've only know what the RF is like from that one position. Also, people tend to, if let's say they're designing to neg 65, they walk to neg 65 and then they stop. So you have no idea what the co-channel interference level is. Because unless you go all the way out to like neg 85, which is, I did a building with a big atrium in the middle and I could walk the entire building for every AP, and we needed, I think, 200 APs in that building. You're not going to walk, and to survey the entire building was half a day. You're not going to do half a day survey. But actually, if you're going to do accurate AP on the stick, that's what you need to do. So and then there's the inaccuracies of how people clicking in the right place, so you walk in. There's inaccuracy in taking on-site measurements as much as there is in doing a predictive with validated on-site measurements. I believe there's the same inaccuracies in both methods.
So good point, and to see if that makes sense. To exactly address that, I like to use 2 access points, sometimes 3 access points, and I'll put them in different locations. Like I'll pull up back a house, I'll say, okay, approximately that's how I think it should look like, and the coverage will look like, and then I will put 2 or 3 access points. I will walk up to neg 85. or -86. I'll make sure I kind of get to that point, and I'll cover a larger area. So not only will give me an idea how the roaming will work and how the interference will work if the AP.
And you can do that when you're just doing 2 or 3 spot checks with AP on a SIG. But if you did every AP location,
Every AP, yeah, I mean that would take a lot of time. Yeah. Plus, also you got to make sure if it's a multi-story building, you go above and below it. Also, just like a look at the floor bleed too.
So let me ask this question because we talked a lot about data, having accurate data, not only for how your RF is modeled, but the location that you're deploying it, as well as the specific spot, frequency, power, all that other stuff. It sounds like data can make or break what you're trying to do, but as we know, the big thing looming on the horizon is AI. Because now it's not just enough that I have a database full of AP and antennas and things like that. Now I'm going to turn an algorithm loose that knows how things should look and what's the likelihood that that wall has this kind of reflection capability or something like that. But what we've seen over the years for any kind of AI product is the worse the data you feed it, the results that you get back are even amplified far worse beyond that. How can companies that are looking to provide services that use modeling in lieu of physical confirmation keep their AI from making these colossal mistakes?
Great question.
it's a good question. And I think for RF design, it's very easy for them to make a lot of design because one thing I think a lot of people forget when because we're very we're so into doing our design and we're so into signal strength and -65, that's going to be my board. We forget that signal strength isn't really an accurate measurement in the first place. There's so much variation in signal strength based upon what device, what orientation you hold your device. So to say on a map at this location I get this signal strength is just rubbish anyway. So I think to then say, can I predict that and could I have inaccurate measurements? Well, of course you can. And it's so easy to get that. I think what we often forget with Wi-Fi design is what we're trying to do. And we're trying to provide a user with a good experience in that location. And I actually don't care, well, the user doesn't care whether they're getting -65, -68, -69. What they care about is, can I connect and will my applications work? And I think what I would like to see is at some point out design move more into that sphere of can we, and potentially how I could help that is, can we guarantee a certain application performance level in a location, not just the signal strength.
So in a way, you're saying is abstract out the numbers that we tend to focus on and work more on the quality of the user experience.
Yeah.
It's interesting.
To build on your point, Peter, I think that I don't know if it's still true, but one of the manufacturers, access point manufacturers, would ship access points plus or minus 3 dB from the factory. Mm-hmm. So if we, to your point about accuracies, inaccuracies, predictive models being good or bad, if they're coming out, theoretically, you have one AP here that's a plus 3 dB AP and another one right next to it that's a minus 3 dB AP. You've got a 6 dB spread between norm on those two APs. So what did we design for, right?
That's a quarter of the power.
Exactly. It's either 4x or 1/4, right? Yeah. So that vast difference just proves the point that you were making about RSSI, signal strength not being necessarily a good, accurate measure of anything. It should be an experiential measure. It should be about what will the user experience. Unfortunately, the only things we have to measure on are SNR, RSSI, things like that are hard numbers. To the question, though, I think of AI and what can they do to keep their products from making egregious mistakes, and frankly, I don't know. I don't know that there's. I think it comes back to us. It's using the product and the AI built into it as a tool to be more productive, but it doesn't take away the need for Peter or Ali. Somebody needs to look at that data, make sure that model makes sense. It passes the sniff test. Then we go and validate, and then it passes a real test. And only then can we say that, okay, yes, the AI did a good job or it did a bad job. Where I think it will help, and what we've seen it helping, is speeding up some of the process. It will help us be more productive. Sometimes it's right, sometimes it's wrong. Cleaning it up often takes less time than doing it from scratch.
If AI, I think, can help with function. So if AI can accurately draw walls on a floor plan for me, it can speed up my modeling. If, can AI accurately place APs on a map? Potentially. I wouldn't like to say it couldn't, but again, does it take into what everything? You still want to be able to somehow validate that that's right.
Still faster though, just to clean it up, right? So theoretically, if I drops 25 APs on there, I figured out I needed really 28, and I had to move some around to make it work. It still got me farther down the road faster. So there's some value in that, right?
That's what I'm saying. It's a tool, isn't it?
Yeah.
But you still always want to validate what you do.
But I would make a counterpoint there. It's just a tool, but in this particular case, it's a tool that can learn from its mistakes. So if we have to adjust the model, if we have to tell it, you got 95% of it right, but what you should have done was think about this, this, and this, then the tool will know, oh, next time I need to take that into account. Bathrooms tend to have thicker walls. Hotels have thicker doors to block sound, so that means that could be a problem. Those are the kinds of things. In a way, it's like we're teaching our junior engineers.
And I was just going to say, we do that, don't we, all the time? The more you design Wi-Fi, you can actually, if you're really experienced, you can look at a floor plan, and I can, without going and validating any walls, I can probably make a pretty good accurate guess of where I'm going to put the APs. Then I can go for my tile design process and probably go, yeah, I was 90% right, if not 100% right, just from experience.
Possibly a centralized database of all this kind of stuff where we, as wireless engineers, we can kind of dump some of the data in there, and it's open source. Obviously, I'm not talking sharing customer data, obviously, but very generic data, like with regards to walls and building types and what's going on right there, something that can be dumped in there and then can be utilized with software vendors to kind of make these educated decisions. I mean, you can do the design go completely blind in, or you can have some kind of educated design done by inputting some good data in there and then get as close as possible. So
and there's rules, isn't it? If these AI algorithms take into some basic rules like place the APs as close to the users as possible, don't put them out in corridors, you can get in reasonably good, but there'll always be exceptions. There's always, actually, we didn't know that wall had lead in it. And that's what AI is never going to be able to fully fix. There's exceptions and that's why you need to validate.
The other point of validating is, we've seen it how many times? We do a predictive model for a particular environment. Maybe it doesn't exist yet. We can't go walk it. We walk in and we see we're replacing an access point be above the most gorgeous chandelier you've ever seen, and we can't possibly put an access point there. But it wasn't evident in the drawings that we had. There was no clarity to it that said that we couldn't do that. So the validation isn't just to validate the actual RF prediction. It's also to validate that those placements make sense. And you can't necessarily go and validate every single one of them, but you do still need to do that validation to make sure that our placement choices are making sense.
Not just the placement choices, though. We're also talking, because part of this also is, or good design is, figuring out what kind of antenna you're going to use, where the placement of the access point, where the IDF and MDF, like all the different closets are, how are you going to run different wiring and all that. I mean, I think all that is also part of a good wireless design. Different paths that the users actually take to go from one route to another. That's also something.
But again, AI potentially could learn that.
There's an old adage in construction: measure twice, cut once. I think that the adage could be adapted to Wi-Fi to say measure twice, place once. But how do you measure? Well, if you only use predictive modeling to measure, then is that the best use of your talents to measure? Should you go on site? Should you trust programs to do it? The answer is not clear. And the reason for that is because we're always constantly refining our craft. We're trying to find better ways to get more effort for the least amount of input. But you still have to do some of the work. And maybe the work means that you're training an AI modeling algorithm to learn how to place access points like you would train a junior engineer. Maybe it means that you need to put on your sneakers and walk around the building with a painter's pole until you know for sure that what you built works. You have to find the right tool set that works for you. Just like a carpenter that only has hammers, you're probably going to run into some things that are not nails. That'll just about do it for this episode of the On-Premise IT Podcast. Thank you very much for tuning in. We publish a new episode about every 2 weeks. You can always find the latest one on our website at gestaltit.com/podcast. You can also subscribe to us in your favorite podcast application of choice. Just search for the On-Premise IT Podcast. Yes, we are using premise correctly. And we'll bring you all kinds of fun episodes about wireless, networking, security, storage, cloud, you name it. It's all focused on enterprise IT. You could leave us a rating and a review in iTunes or whatever application you use. We would really appreciate it because that helps other people find us and lets them know what we're all about here. We'll be back again with another great episode pretty soon, so stay tuned. Thank you for tuning in.